Uh, Now, I'm gonna teach you how to use bisection method on some problems in strength of materials. We have here a simply supported system having a concentrated load of 5 kilonewtons and 10 uniform loads. If we apply all of these forces and make a general moment equation, we'll have these equations, which is the first one, EI y double prime is equal to 5x minus 5 quantity x minus 1 quantity minus 10 over 2 quantity x minus 2 quantity raised to 2. The second equation is EI y prime is equal to 5 over 2 x squared minus 5 over 2 x minus 1 squared minus 10 over 6 quantity x minus 2 raised to the third plus C1. The third is EI y is equal to 5 over 6 x cubed minus 5 over 6 x minus 1 raised to the third minus 10 over 24 quantity x minus 2 raised to the fourth plus C1 x plus C2. And using our boundary conditions, which is y is equal to 0 and x is equal to 0 and y is equal to 0 and x is equal to 3, we're gonna have the value of the constants, which is C1 is equal to negative 5.093 and C2 is equal to 0. And therefore, the general moment equation is EI y is equal to 5 over 6 x to the third minus 5 over 6 y minus 1 to the third minus 10 over 24 quantity x minus 2 raised to the fourth minus 5.093x. So, assuming the values of 0 to 1 is the x, for us to get the distance of the maximum deflection, we're gonna have an equation of 0 is equal to 5 over 2 x squared minus 5.093. And therefore, using algebra, we're gonna get the value of x, which is positive negative 1.427, which is not in range. So, we need to assume another value, 1 and 2. We're gonna assume the value is between 1 and 2. So, using the general moment equation, the only terms that is inside the range is 5 over 2 x squared minus 5 over 2 x minus 1 squared minus 5.093. And using this equation, we're gonna use the bisection method in order for us to get the root of x. And from this table, the first iteration will be the XL will be the range and XR will be the upper range. And the first iteration is 1, 2, and the XR is 1.5 and 0. The second iteration is 1.5 is the XL, XU is 2, and XR is 1.75. The error is 0.25 and the required error is less than 0.1. So we need to continue the iteration. The third iteration is 1.5 is the XL, 1.75 is XU, and XR is 1.625. Still, the error, which is 1.25, is greater than 0.1. So we need to make another iteration. The fourth iteration is XL is 1.625, XU is 1.75, XR is 1.6875, and the error is 0.0675, which is the accepted value, and therefore the root is 1.6875. So that's how you use bisection method on strength of material problems like this simply supported system. Thank you.